So yeah, good evening. So as I was saying, this week we are doing data onboarding. So we have so far at least studied. The expectation is we now know how to configure, a Splunk environment, how to deploy some components of Splunk. We've started from just a single server. We saw how we can, connect, how we can make that do for us what we can. And we know right now, I mean, for the short time that we've been learning Splunk, that Splunk is all about data. So it's you being able to, ingest machine data into your deployment, which you have configured or you have set up, and then at the end of the day, be able to analyze that data and, then try to interpret it or, use it for whatever, requirement or use case that you have, try to bring out whatever metrics or whatever you're looking for. That's why they say Splunk is data for everything. So far, what we have been doing is, first of all, know what our components are. So we've seen or already established that, we have the processing component, we have the management component, and we know the processing component, the forwarders, the indexers, the searchers, and we have studied, and at least I expect now that in basic terms, understand what is a forwarder, what it does, the basic responsibility or the functionality of a forwarder, what is the relationship with the forwarder and an indexer, and what is a search head? In what cases do we need to have a dedicated search head? How do we configure, do we make that happen? All these instances together. So that's what we've been doing so far, is just making sure that we can set up our environment, make it ready to then bring in data. So we are at a point where we feel like we can now manage a large environment. We know how to use one of the management, component, deployment server, to deploy apps and configurations to like a bunch of different clients. We've seen that. So we're at a point now where we say, okay, we have a scenario where we want to bring in data, because that is where you see the value of Splunk, is when you bring in data into Splunk and you're able to then analyze that data and use the same source, that same single data source, for different purposes, different use cases. You can drive different value from that data. That is the value. That's where you start seeing value, when you create dashboards. And it's just that we cannot just jump to creating dashboards and running searches. You have to know what happens behind the scene, because you are expected to be the Splunk expert. Like if for the executives, like the people that, the CTOs and all of those, they do not have to know how the environment is set up, how the data comes in. All they need to do is see the end product. This is what, Splunk is bringing. Because of we are using, or we deployed Splunk in our environment, we're able to, monitor and identify vulnerabilities. We're able to, identify threats before they even happen, and be able to put in corrective measures to combat those and all of that. So you, as the engineer, you need to understand how to set it up, bring in the data, and then be able to analyze that data and create valuable content out of that. So we have so far learned how to set it up. Now we're going to learn how to bring in the data. We've already touched on it a lot. I mean, we bring in data. We've seen, how data comes into Splunk. We're just going to go into a little bit more detail on how to bring in data, what are the different types of data you can bring in, and how you can, manage those different types of data, and, going forward. So any questions so far with regards to, what we have said so far, where we are and what is expected? Okay. All right. So the scenario today is that we are asked that, and the expectation is you would see that I have just 2 servers here, and don't take it when you see, going forward, when you see me have like 2 servers, just 10 servers, I create the resources that are needed to show whatever concept I need to explain. So I expect, like, the expectation is we have an environment already that is running. We have a bunch of forwarders deployed. We have a deployment server that is pushing apps, but we're just dealing with a specific issue that we are asked to onboard data, to ingest data into Splunk, to go configure, some ways we can bring in data. So that's why for me to execute that or to show you that, I need at least these 2 servers. So it doesn't mean our environment only has these 2 servers. This could be my test environment. It could be that we have a prod, environment, which is where we have deployed our full, all the instances, everything is working fine. We have our test environment, because always that's the case. You'd have a test environment where you would go and test and make sure things are working the way you expect them before you then deploy them. So that's basically an example of that. So today we're looking at bringing in data via the method called monitor input. Monitor input is one of the most popular ways of bringing in data into Splunk. And you see what we have here. We have a dedicated machine that is a forwarder that we would use to collect the data. And we know already the functionality of the forwarder. You install the forwarder at that endpoint where you are collecting the data. So directly at the source, you install the forwarder there and then collect whatever data. And we are going to then send that data to our indexer / searched, which so a single machine we can use for both functionalities, and then see. Because today what we want to see is just how we bring in the data. We know already how, if we wanted to have a large distributed environment. So monitor input, I want to put the question out there. We've talked about monitor input a little bit here. What, who can, let's give just short answers. What do you think of, or what do you understand when we say monitor input?
Is an example of that API, like bringing, because you said monitor input is bringing data in. So are examples of that like where the forwarders are taking the data from?
So API is another type of input. So that is different. Monitor input is different from API. API input will deal with maybe Thursday, but it is different. What do you understand when we say monitor input?
Yeah, on my side, I don't know then. So monitor input is a specific way to bring data in then.
Yep.
Okay. Yeah, I don't know. This is new to me.
So what is that way? How do you explain that way? What does it mean when we are saying we are monitoring a data file or directory?
So maybe like the process of like collecting and analyzing the data from various sources.
Okay, that is general input, but we are talking about specific one here, which is monitor input. Yeah, it's all collecting data, but in specific monitor input, what would you, like, we have keywords there, monitor. They're all input, but this is monitor. What would that tell you when we say monitor?
So maybe like give you real-time analysis on the data.
Yes. So the analysis part is when the data is in Splunk already. That's when we go run queries to analyze the data. So right now, what we are talking about is trying to bring in the data, what configurations we need to establish for the data to be ingested correctly. So all data, when it comes into Splunk, you can analyze it. When we say monitor, what is the meaning of monitors?
I think monitor means you're constantly looking at something.
Right. Yep. That's the key word there. So yeah, constantly looking at something, continuously looking at something for whatever. So monitor input is when you decide, or when you tell Splunk, or when you tell the forwarder to continuously look at a file or a directory. So look at this file. Whatever new data, whatever new, even if a single character that comes into this file, I want you to grab that and send it into Splunk. And we mean here Splunk, the indexers, index that data so that I will then be able to analyze that. So it does not just take it once. When you set up the monitor input, it grabs whatever is in the file at the moment and then continuously look for whatever new data that comes into that file. So continuous looking at the data. Good point. So I have a short PowerPoint, or presentation that will just go. Today, the plan is for us to do the monitor input and also some scripted input, because we have a bunch of input types we want to use this week to do, the different inputs. So let's see how far we can go. Okay, as we've said, we're gonna do a monitor input first. So monitor input again, here you define a single file as the source with the input settings for source type, host, and index. And we would see what these are as we go down. But basically, source type is just the type of data. Every data has, what kind of data is it? And the host is just the machine or device or appliance or whatever that is hosting that data. And index is the location where you're sending the data to. You can, and so these fields are called the metadata fields. So these are things that you have to, information that you have to give when you are defining an input. You have to tell Splunk what kind of data is this, what device is bringing in this data. It does not mean that you have to hard code these values. Splunk has a way, and that's one thing we'll, try to identify today, how Splunk would, if you don't give it a host name, how it would identify and say, this is the host name. If it does not have a source type, how do you do that? Index, you always have to send it. If you don't give an index, we have it set by default to send it to the main index, we've said already. But basically, monitor input is a way we ingest, the current content of the file. So we can monitor, we see here right now, we're talking about files. And monitor, we can do it on both a file and a directory. We know now the difference is here between a file and directory. A directory is just a folder that has other files or other folders inside of it. A file now is directly going to, that single, file. Here, it can be a TXT file or whatever, or if it's the varlog, inside of varlog, we want to see secure.log. So secure.log is a file. We want to then monitor that file and, continuously whatever that comes into that file. So, and that is again the keyword there, continuously monitor for any new content. So it would ingest the current content and then continuously monitor any new content using the Splunk fish bucket. Splunk fish bucket is another functionality that we would study today. That is one of the, reason why a monitor input is the like most popular, or using a forwarder to collect data is the most popular way of collecting data. So Splunk would tell you this: if there is any way you can use the forwarder, use it. And one of the, you can use forwarder for other input types, but monitor input is the general and most popular. And basically, what you're saying is you're just telling Splunk that look at a file inside of that forwarder. You install the forwarder on the agent where you're collecting the data, and you're saying a specific file or directory on that machine. I want you to continuously look at that file, whatever comes in, grab it. So that is the safest way. Because of the fish bucket, Splunk is able to remember where, you know, it stopped when he was reading the file. So if he read it and came to like a character, let's say, for example, the machine restarts, the machine where the forwarder is installed, for some reason, maintenance, you know, it was restarted and it came back up, Splunk would remember where it stopped reading the file and then continue from there. Because we know that Splunk is a daily license. You know, that's how you pay for using Splunk. So it's how much volume of data you ingest. So you don't want to re-ingest the same data. So for example, if you have secure.log, you have started bringing in, you know, content of that file, and you lost power on that machine, it stopped and then starts up again. And you now, Splunk has to go and then go grab the whole file again and re-ingest everything. So you are duplicating your information. You'll be charged double for the same thing. You have this event in Splunk already, you're bringing them again. That is at your own cost. So you don't want to do that. That's why we have the fish bucket that would help, you know, with that regards. There's a checkpoint. We'll talk about the fish bucket more, but again, we see here, this is talking about files. It's the same as directories. Monitor a directory. We define a directory like a tree, you know, as the data source. And then recursively. So recursively is, it looks at the directory and every little thing that is inside of that directory. Either if it's another file or another directory, it will go into that subdirectory and look at it, whatever is inside of it. So recursively traverse the directory and monitor all discovered files. If there are zip files, if there is zip content in that directory, it would unzip or uncompress it, and before it's ingested. So that's why monitor is really you know, popular, because it is really of huge functionality. So it includes, and this includes new files that are coming into that directory. So if you've started monitoring a directory, right, and later a new test file is created, it starts coming into that directory, Splunk would catch it. So that's why you're saying, for example, I want to monitor var log. Whatever is in var log at the moment that you defined that stanza to monitor var log would be grabbed and ingested into Splunk. And then going forward, it would then continuously look at var log, whatever new files or new directories or inside of the existing files, whatever new data that comes in would then be ingested as you go. And it can detect and handle file log rotation. So, you know, log rotation is when the logs or files in a directory, it goes to a point where they are full, they reach the maximum, you know, the capacity that you've defined for that log. It will rotate. That's where you go. You have maybe secure.log 1, and then you say secure.log 2, secure.log 3. So that is rotating. It will go to, you know, different versions of the file. So the monitor input would identify if the file rotation has happened and continuously look at the new, you know, files that are created. And I mean, that's what we see here. So basically what we've defined is monitoring a single file, which is going directly specifically to that file, or deciding to look at the directory, which is look at content of the whole directory, whatever is in it. Any questions there? Okay. All right, so just an example, I like pictures, you know, now here. So an example of, you know, how we can monitor a file or a directory. So we have our forwarder. So this is our forwarder. We know it's collecting the data. It would eventually send it to the indexer. This is where the data would then be stored. So here, this is like a machine or whatever, maybe a web server or application server. We decided to install a forwarder on it. So we are saying that look at, you know, monitor this OPT directory. Inside of OPT, we have log, and log we have, you know, and sub. So you see, we have the directory OPT, we have subdirectory log, Inside of the subdirectory log, we have crash log, which is the logs, and another directory, ww1, that has other logs. So we have subdirectories that have, then individual files in them. So when we are monitoring OPT, it would go in, look at this log, and you would realize that we have these two directories inside of log. You would go into the two directories again, to the bottom, to the last file, and looks at these files, all the files in it. The same here, because home is in the part of OPT, it goes into home again and looks at everything. So that's basically what we're saying. Look at OPT, whatever is inside of there that matches the whitelist that we give, capture that data and send it to whatever location inside of the indexer that we have defined. Any questions here? Okay. All right. So in the in us defining or setting up this monitor, telling the forwarder to grab this data from this file or directory, we have a format. We have a way, we can define the structure. We know already that monitor, when we want to bring in data, we want to capture data to send to the indexers, the configuration file that is responsible is the input.conf, because that's what we use to bring in data. So we're saying that this is the format that we can have on the input.conf. Inside of it, we have the stanza. The stanza is anything that is in this square bracket. So you see, starts and ends in the square bracket. So inside of that, we have the word monitor, and then colon to forward slash. So after that, now you have the path to whatever file or directory you want to monitor. So it could be varlog secure, varlog access, whatever, or just varlog. So if there is a forward slash in front of the directory, so let's say we wanted to monitor varlog, so it would be monitor colon forward slash, because var is a root directory that has another forward slash in front of it. So it will be a third forward slash and then var and then forward slash log. So you remember that the format is here. We have two forward slash and then the path. So don't forget, if there is a forward slash that starts the path, you have to list that there. And then inside of this is the stanza, right? That's the stanza header. Now we have whatever attribute we have defined inside of the stanza, and this is how all configuration files are set up. You have the stanza in the square bracket and all whatever you've defined inside of the stanza, and then this disabled is just telling Splunk that this whatever I would define on this stanza should be looked at or not. So if you say disabled equals false, meaning it's not disabled, it's the opposite, or just saying that this is enabled. If you say disabled equals true, so it's either 0, which is false, or false again. If you want it to not be looked at, you say disabled equals 1, meaning it's disabled or true. So these are just the different values you can provide for disabled, 0 or 1, or true or false. And then the source type. So when we are bringing in data into Splunk, we have to tell Splunk some information about that data. So we call that information metadata about the data. So, and some of that information is the source type. Again, we talked about that earlier. Source type is just the type of data. What kind of data is this? Is this a system generated data? Is it a web, log? Is it a security log? Whatever kind of data. Is it a JSON format data? Whatever kind, you have to tell Splunk, because with the kind of data, Splunk has already pre-trained. So because it has been around for a long time, it has common with the application. Splunk, the platform, understands some common data types. So it knows that these are common data types that are ingested into Splunk. So configurations have been built already to handle those data types. So that's why you have to tell it the data type. This is a string, it always be. So it could be source type equals syslog. Syslog is a pre-trained a source type, which when you tell Splunk that this is a syslog source type, it knows already what is the format of a syslog, a log file that comes in, how to look for the correct timestamp, how to break the event, up into different, the boundaries, where to break the event, how to, extract the host field and all of that. So it would know. So that's why you have to give it the source type. If the data that you are bringing in is not a common data type, because it would always be the case where this is like maybe something that is new, is a new, for example, a new application, someone create a new app, and the data generated is not a common source that is ingested into Splunk. You have to tell Splunk that this is what my data type is called. And because configurations have not been established already on how to handle that data, you would then, when you are configuring passing of the data, you would tell it, this is how you handle this data. This is how you identify the event boundaries. This is how you extract timestamps. This is, everything. You would tell it. So those are we call custom data sources that you would configure. So source type is very important. You have to make sure you give a source type. So that tells us if you're monitoring a file or directory. So if it's a file that you're monitoring, definitely you want to tell it the source type. So Splunk is intelligent enough to try to guess or understand. You would look at the data, and if you don't list a source type, you would look at the data type and understand, I know this format, this is what it should be. It would give you from its own understanding that this is the source type that should be given to this data, meaning if you don't give it. But if you are sure this is the source type, it's better you tell it. Because if you don't tell it, the machine, so this, that's when you start wasting unnecessary CPU cores or processing power on things that are not necessary, because you would have to use some resources to go and identify what data type is this. If you know it, if you're monitoring a single file, like you're monitoring var.log access.log, and access.log is, the source type is syslog, tell it that this is syslog. If you don't tell it, you will try to identify it. But if you were monitoring a directory, and inside of the directory, you have subdirectories and other files. So it is possible that all the data in that directory are not the same source type. So we have different data types in the directory. So it's not wise to say I'm monitoring var.log and I'm going to say syslog for everything. Because if you say var.log, that's what you're monitoring, and give the source type syslog, even if that data type is not of syslog, because you have explicitly tell Splunk that this is syslog, it will just assign syslog to all of it. So that's when you start having mismatch and all of that. So mostly when you're monitoring a directory and you're not sure of the exact data type that would exist there, you would leave the source type blank. Splunk would try to identify the source types, or you can break them down into, go to the exact file and tell it the source type. Index is where the data is sent to. We said index is like the indexer is the house. Inside of the house, we have rooms. We have the master bedroom, the living room, all, the kitchen, everything. So the index is where the location where you're sending the data. You have to tell it. If you don't tell it again, it will try to guess and send it to, the main index. And if you know already that this is where I want the data, you don't want it to be sent somewhere else. So you want to identify those. You can blacklist or whitelist. So inside of, for example, of a directory that you're monitoring, like you have a whole directory, you maybe don't want to just capture everything in the directory. You can say, I don't want these XYZ files. That's when you would use regular expressions. So regular expressions is just a pattern match. So you say, look for this pattern. Don't grab that anything that matches this. Don't take it. you can whitelist. We know blacklist is you saying, I don't want this. Whitelist is you saying, this is what I want. So you can use a regular expression to whitelist or blacklist. And there are a lot of other attributes that you can add to the monitor input. You can reference the either the the README input.com spec file, or you can go to the Splunk documentation, the web on Google, and just and see what is input.conf, the spec, the file itself, and see how monitor input is set. But these are the metadata that we can establish. So the source, the source, so the metadata fields are host, source, source type, index, and time. So these are 5 general main metadata fields. So the time is mostly, identified by Splunk. That's or you can define if it's not a common data type. You can define as you go. You can define when you're passing the data. So Splunk would look at the time and say, this is a timestamp. Index, we know that's where the data is sent to on the indexer. Source type is the type of data. This here, monitor, when you say monitor and give the path, that is the source. That is where is this data coming from in my machine. So that's the source. So source type, index, time is whatever timestamp that you collect. So those are the metadata fields. These are things that you have to define before you bring in the data. Any questions here? All right. Okay, let's move on. Okay, so now we have seen how we can define the the monitor stanza and all of that. So inside of now an example of the the direct, let's say we are monitoring something. So we know we said we'll say monitor and then colon and then 2/ and then the path. So you see here, that's why it's in green. So we're trying to capture var log ww1 secure.log. So this is specifically going to that exact location of secure.log and capturing that log itself. So this is being as explicit as possible, capturing the exact file. We don't want anything else. We just want to capture the exact file. So you say var log ww1 secure.log, and you can see here, so inside of var log ww1, there are other things in there. So these are the possibilities it's telling you, because you gave an exact path for your monitor. It goes in, it says var log ww1 secure.log. It does not take any other thing. See, this say var log ww1 secure.1. It would not take that because it is looking for exactly secure.log. This one say var log ww1 logs and then secure.log. We don't have that in our part. We don't have log here. So it ends with secure.log, but there is a logs in between the ww1. So it does not capture that as well. Var log ww2, no, we're looking at ww1, so it does not capture that. So this is being explicit. That's what we are capturing here. So we will learn you have the options to also do globing or use wildcards. So wildcards is when you can use, we've seen how you can use the star, or use regular expressions to capture other characters. So in this second here, we say monitor var log ww1. Now we're not going specifically, we're looking, maybe there are other things that has secure. So we say secure dot, anything that says secure dot and ends in something, capture it. So you would look at here, var log secure.log, yeah, that matches what we want. Var log ww1 secure.1, so that is captured as well, because we say anything, the star says anything that comes, like any file, any on this part, ww1 secure dot, anything that comes after that, as long as it match, capture it. But in the third one, we have logs after ww1, so definitely it does not match that, so it would not take that. ww2 again is not in this view, so it would not. So you see the pattern here, and then we can even add. So now here we're saying monitor var log www. We are saying in this case we have the possibility that there are maybe numbers or some letters after www. So it could be www1, www2, 3, or wws. So we're saying, look at the directory, that www, and whatever, you know, letter or symbol or whatever character that comes after it, and that ends in secure dot again, whatever that comes after it. So you see, we're capturing more now. So it goes into varlog www1, we know that already. And again, this www1 secure.log. This one says varlog ww1, which it should capture, but because there is logs in between the secure, that does not match. It says, but you see this time now it says varlog ww2, because I give this asterisk here, or this wildcard here, it is capturing it. It captures both 1 and 2 now, because I say www and anything that comes after that, and then secure.log. And here now, we're even making it more open. We say monitor varlog. Now, these 3 dots, what we are saying is, remember, we had this www1 or whatever www. So we're saying now, 3 dots, try to traverse whatever is in between. So look at varlog, and whatever is in between varlog and secure.log. So look for any file that ends in secure dot and whatever that comes after that. It doesn't matter, as long as it's in this part varlog. And when this 3 dot, it would look at the directories in here. If you have 10 other directories in here in the path, as long as they're in the path of varlog, and then the end of it is this secure. So you see here, it looks at it, say varlog ww1, which we know is inside of log, right? And inside of ww1, we have logs. So it still captures that log. So there are 2 directories in between here, but because you give this 3 dots, so traverse and look for anything. I'm looking for something that ends in this secure dot star. So that's why in this case now it captures everything. So you have to know regular expressions a little bit. You have to know how to, you know, match exactly what you want, or you would end up capturing unnecessary data and ingest it. And again, that would affect your license, or not capture what you need, or you would like write an expression that would not capture what you want. So it's either ways. So either you bring in data that is not needed, or cannot bring in what you need. So any questions here? Are we all getting it? Is it making sense?
Yes, it is.
Okay. All right, so let's move on. Okay, and this is just now what here was us defining the source. We were defining the source of the data, and say we can directly select the file, or we can, you know, open it to, you know, multiple files, or we can, you know, even capture directories and all of that. And, you know, so now we're saying inside of, we have already defined that we are looking at varlog ww1, that is the path. Inside of that log, I can add whitelist. So you are saying I've defined this, but I want to now look for whatever in that directory ww1, look for something that ends in .log. So this $sign here means ends in. So if you, anything that ends in .log, that's the $sign, meaning the ending. So anything that, any file that has the ending .log, this sign here is called an escape character. So you're telling it that you know, escape this. So it's a special character. I would after the class, I would look up some regular expression videos and just share those with you, so you can see what regular expressions are. So this is an escape character. You're telling that you know, you would see what are escape characters. I don't want to go into that right now, but we're saying anything that ends in .log, capture that. So you're saying here, it does not care as long as we are in this part ww1. So it captures all of the .log. This one says access.1.log. See, it captures access, it captures DB access. It captures access.1.log as long as it ends in .log. This
Question.
one, see, it ends in .log.2. So meaning the .log is not the ending. So that's why I didn't capture this. So it's capturing this. So you're saying here anything that ends in that. Joseph, I see your hand up.
Yes. If it to capture that .log.2, would that whitelist need to say .log then the money sign? Would it capture it?
If it said .log.
Yes, with the money sign at the end.
No, it
Would it
has to
capture?
say if this dollar sign here is saying that this G is the last character. So you're saying that the last character in the path that you want to capture should be G. So you're saying .log. So
What
if
if it
you
was
wanted to capture this .log.2, you can say .log.2.
okay? Is there another thing that we can? Is there another character that we can use for a number? Because what if it was like, what if the one above it was .log.3? How about we capture that?
So no, it does not matter if it's a number or letter. It's just, this is just saying, this sign here is saying that it is the end. So if I wanted to look at this pattern, I have to include that pattern in there. I'm saying .log, and this is .log. These are the ones that end in .log. So it would not look for anything after. So remember, G is the last character there we're looking at. So and dot is not included because after the this we're saying the end. So definitely this path here does not end in .log. If I wanted to say I want to capture .log or .2, I can have let's say this other things has maybe .log, .1 or something. I could do a regular expression here and say .log and have like an asterisk here, which is a wildcard, and say end. So you could say .log and then something that comes between that and then end. So again, try to review regular expressions. It has, it's a whole thing on its own. You have to understand what are special characters, what are escape characters, how do you, basic regular expressions. So I would have given a wildcard here. If I wanted to capture this, let's say there are more files that ends in this way. I want to capture that. I could write it in a different way. But this that I express here is capturing this. And because these are the ones that matches, that .log. Clear?
Yes, sir.
Okay. And this other one here again, the same thing, looking at Verilog WW1. But here now we're saying we want anything that ends in query and then escape character .log. This pipe, this is a pipe symbol, is it means or in regular expressions. So I'm saying I'm looking for something that ends in this format or this format. So it would look for both would work. So you can have multiple or, so you could have added another pipe and say other thing as well. So that's why here we can see you would look for query.log. So you see query.log, that's that. And then query db query. So the same, it still ends in query.log. Now WW1 my is not query. So you see that's when it goes the it's the my log, my.log. This one now say WW1 my.log for J. And that for J is not part of we say the last character is G. So we don't have 4G. That's why it's leaving that out. So that's it. So regular expressions are just pattern matches that we're doing. And this last one here again, whitelist, query, and then .log or that, and then you would capture just that. So you can, reference that. Any questions there? Okay. So we have seen, we know now how to define our monitor stanza. This is not the first time, and how we can add whitelist. We know the metadata fields that we have to establish or give it so that Splunk knows exactly what to do. So now we're saying one of the metadata field is host, right? So when we are building our input.conf monitor, so inside of input, remember one of the commands that we run, there is a command that sets the host name. What is that command? Do we remember? So when we want to change the host name and server name.
Did you repeat that? Sorry.
So there is, or there is a command or configuration file, whatever you give me, there is a command, that we use, to set the server name and host name for our whatever server that we have. Like if we want this server to be called indexer, we want it to be called Sadija indexer, there is a command we set for that.
Host name CTL space set host
That's
name.
for the that's for the machine. That's for just naming our machine. That does not have to do anything with Splunk. I'm talking about Splunk command. So let's not confuse it. That hostname CTL is a system command. It's not a Splunk command. That's basically for for me. So if I have multiple instances, I want to make sure that I identify that this is my indexer, the other one is my forwarder. That's when I do hostname CTL. It would not change anything for Splunk. I'm talking about a Splunk command that would change the server name and host name for Splunk.
Shouldn't it be in bin? It would be the set server name.
I want you to be sure. Don't ask me again. Just yeah.
That's what it is. It's in bin, the set server name.
And then the server name. And how about the host name? Or how do you set it?
It would go OPT Splunk, bin Splunk, set default host name.
Default host name. Yep. So when you set those, it would have inside of input.conf, there will be something that we call a default stanza, and we know stanza is this whatever is inside of this square bracket. So let's say if this was our input.conf, inside of here would have a default stanza. Let's even see that here. So this is our forwarder, right? So if I go, because I set the host name and server name here, I think this is the indexer, this is the forwarder. So if I sudo su Splunk, I think underscore user. Now, if I go to cd to Splunk etc system local, instead of local ILL here, we have input.conf, and this was created as a result of me setting the host name. If I cut my input, instead of input.conf, we have default, and then we said host equals Sadija, and then the name that we give it, because we said that set default host name. So I am saying in running this, there will be a default stanza here, and that will set a host name. So inside of my monitor stanza, if I don't define the host, if I don't say this is the host that I want, this is how I want you to name this data that is coming from this stanza that I defined, it should be called that this is the host that it comes from. If I don't set that, it would use the default configuration, which is this. So in our case, that's what it will be using. If I wanted it to have a different host name, I would set it here. Either set the value, say host name equals XYZ, and then whatever that comes from this part will be XYZ. Any questions there? I just wanted to identify that.
Are you putting that above the monitor stanza?
Yeah, it has to be up. So you see right now, inside of input.conf, this is the only thing we have there. Default is the general. So default is the stanza on top. So whatever we don't specify would use the default configurations. Yeah, it has to be above. Okay. All right. So what now I am saying, I went back to that is we have seen right now, whatever data, if we don't specify it in the monitor stanza itself, it would use this as the host. So inside of I think I logged in already here. If I run this, so we say our internal data, whatever data that comes from that forwarder, this is the host that it would report as. So because that's the default one that we've set. But we have options to give it, a name, either hard code the name, or tell it to use some logics to identify the name of the host. Because it is possible that our forwarder is like a server that is receiving data from other maybe network devices or some other things. Sometimes we have syslog servers. We have servers that we would use to aggregate, to receive and aggregate our data, compile that data, and then we'll in turn now send that data to Splunk. So in that case, because the data is coming from other servers, maybe web servers, application servers, or other appliances or apps before they come to the server, to our forwarder, if we say the host for all that data is the Sadija forwarder, that will not be accurate because we want the data to be represented correctly. So that's what we are talking about here, how to override the host name. So by default, it would take that name. But if we know that maybe these are log servers, inside of log servers, we have www1, www2, www3. This is, and we want that data to be represented. So that's the example I'm giving. This is our forwarder, right? And our forwarder is receiving data from this web server, www123. We have, like Amazon.com. They have that lot of, so like Amazon.com, when you log in to the server, when you log into, or when you launch the browser and say Amazon.com, you just launch, you go to Amazon.com, but behind the scene, they would have hundreds of servers that are deployed to, just support the content. So when you put in your order or do whatever thing, there is a specific server that is running or supporting that whatever you execute. Now you are have a general forwarder or a machine that is the central location where you're collecting all the servers that are supporting our web interface for Amazon. This is just an example, right? They are sending it to a general server. You call it your syslog server. Here you are aggregating that data and then forward it to Splunk. So it would not be accurate to say that server is Sadija forwarder because they are coming from different. So if my data is coming from www1, I want it to be shown the host www1, the same as www2 or 3. So in that case, you can use different ways to identify that. So we can explicitly set the host value using the following ways. I mean, you can use the specific value. So if I wanted it to be www1, here I can say host equals www1 after inside of the definitions, host equals www1. Instead of me using this default host, I can define host inside of this setting here and say equals www1. Or I can use the directory name. So these servers are sending data to the forwarder, and this data is being written to varlog. Inside of varlog, we have these directories, www1, 2, 3. So whatever that is coming from this server, www1, is being sent to this directory, same www2 and 3. So we want the data that is being stored in this directory, because we would be monitoring this directory to have the host name www1, 2, and 3. And we have another one, mail logs, that are mail servers, and there are files inside of there. We want maybe the files to be called that. So we can either use the directory name. In this case, they will be www1, 2, or 3, or we can use the regular expression. We've started the introduction to regular expressions that would show us the name. We can use that to either list the directory name again or the actual name itself. So how do we do that? Setting the specific value is easy. We just say host equals, if I wanted to say be XYZ, I say XYZ. In that case, it would just be XYZ. That's that direct. But if I wanted to, let's say, use the second option, which is for it to be whatever directory that the data is in. So when these 3 servers are sending data to my forwarder, the forwarder will send it to the indexers, or inside of the forwarder, the data is in var log, inside of log, ww123. I want when this data goes to the indexer for this whatever data that comes from here be ww1. So I would list it. So inside of it, we have now we call it, using the directory name, you use the host regex format or notation. So host segment. So segment is just the path. So inside of the directory here again, you see the path. So the path to get to ww123 is var log and then ww1, ww2, and 3. So you're saying the segment, so you will be var is 1, 2, 3. So is the number, you can check that. So if I go here now, it's saying to set the host, make sure that the host name is the directories where the data is coming from. You set it host segment, so host segment, and then give an integer, so it's a number. And this setting host segment to 3 uses the third segment in the directory path as the host name. So again here, var log, these are the names, so it will be ww123. So inside, everything we can do on the web itself. We can do it on Splunk web, or we can create a monitor stanza in input.conf and do it. So if we were doing this on the web, so on the web, mostly we know a forwarder does not have a web interface. So that's the first case where that's why you don't even want to entertain the idea that you want to do this on the web. But I'm just saying, if this was a heavy forwarder, you wanted to set it on the web, you go to the add data, you set everything, and then in the before you submit the data, you set the host. So let's see that in our Splunk server. So here I am assuming right now that this was my forwarder. This is a heavy forwarder. I'm trying to collect data, for using this heavy forwarder. I don't want to go and create the configuration file and edit it. I can come here and go to data input. And then inside of here, it gives me different things to do. I can then set, directory. I don't have data right now to set. I said, right, these are the default defined directories, files and directories I can monitor. I can say new directory location. And inside of there, this is where I specify the file location, the path, where I say monitor stuff, that's the same here. So let's say I wanted to monitor var log, let's see, var log. And inside of var log, so I just wanted to monitor var log. So select that. Did I? So go again. I didn't select something in var log. So let's see. var log. Let's see the log. Select that. So I want to capture this var log, right? And inside of that, there is a directory called SA. So inside of SA, we have sub files and sub folders. So inside of, I mean, this is not an exact example. I'm just showing you, if you were doing it here, how we'll do it. We'll do an exact example where we would bring in ww1 data. So if I wanted to capture this and I've set all the other things, I say next, I set the source type, I've set the source type, everything you see here now is where we set the host name. How should this data appear? I could say use the constant value. So constant value, I can set the name here. If I wanted it to be Sadija IDX or whatever the host is, I can set that here. Or I can say it is XYZ. XYZ, I can say that's the host. That's setting the constant value. That's what we saw here, right? Setting the specifying the value. So now I can use regular expression. Regular expression is me looking for a pattern match and say this is what I want. That's how I want the you to look at. The third one here is segment in path. So segment in path is me putting a number. So I will put, I know in the directory path, I'm looking for var, log, and then SA. So use the SA. So I say 3. So var log SA. So segment path 3. So that's what you are seeing here. That's what it's saying here. So you can either select, if you are doing it via a web interface, you can select the segment in path and then state 3, which is what you see there, or create the file itself or edit the file and say host underscore segment equals 3. So it's either or, we know now. So that's what we're saying there. I just wanted to, show you how you can do that. Any questions there?
I'm still
Okay.
like confused when we would use the host segment versus the host name. I mean the original.
So that's what I was explaining here. So we have multiple other machines sending data or other servers. All the data is in this forwarder. Now this forwarder is the one that is connected. These ones are not connected to, are not going to send to our indexer. So if I set here, so our definition is this is our forwarder, right? It is sending to the indexer. This is where the data is indexed. So we are talking about what is defined on the forwarder here. So that's what we are talking about here. So this is our forwarder. What do we define here? If all these other servers are sending data here or logs here that is then aggregated before they are sent to the indexer in this picture that we see here, we have to make sure we properly tell Splunk how to identify the host name. If I give the value as just that Sadija underscore UF, it would, all the data that comes from www1, 2, or 3, or whatever, would be called, the host would just be named Sadija UF. And that would not be a correct representation because we would not identify. It would be hard for me to know if I am troubleshooting. I wanted to understand what data was captured by www1. I will not be able to know that because now everything is showing as host Sadija 1 or Sadija, whatever I name it. So that's why we're saying are different options to override that host name so that it does not show as just a single host, so that it would actually capture the source, the actual source of the data itself, instead of just the forwarder that is collecting the data.
Got you.
We are trying to represent the data from the source itself rather than the forwarder that the data is being collected from. Okay?
Yes, sir. Thank you.
So yeah, so that's what we're saying there. So that's the segment in path, the 3. Again, we could have used the third option, which is host regex. So the other one is host segment, which is numbered, and you say equals 3. And we're saying here an example is var log inside of var log, that's where we have ww123. So we're saying use these names as your host names. So that's why we say the segment is 3. The other option is we wanted to name these other files, IIS something, IIS vmail, whatever, right? Inside of this directory, vmail logs, we have log files that are there. These are the sources. We want the host names to be named as the actual log file names. So that's why we'll say now go into that directory, var log vmail, and then set this regular expression. So this regular expression is say capture any word character that has this vmail, you see vmail dot, and whatever that comes after that, and that ends in, you see that, remember that ends in .log. So all of these ends in .log, but in the middle they have that vmail. It could be IIS or whatever that is in front of it. So again, it's regular expression. So that's what you're capturing here. Host, you see the way we're defining it, host underscore regex equals, we set the regular expression. If we're setting the segment, we say host underscore segment and set the segment path. We're setting the value. If we just want to give it a constant value, we just say host equals. We don't put anything after the host. So host equals the host name if it's the constant value. If it's the regular expression, host underscore regex, and then segment, host underscore segment. Questions? Are we clear? Is it making sense? Okay, let's move on. So now we've seen, those basic things, because apparently we've seen how to, bring in data, how to monitor data. I mean, so I just wanted to identify how you can, understand, and identify and make sure that your data is represented correctly. That's why we wanted to explain that. So now you've brought in your data, and then maybe the data is not showing because you would have this a lot. Data onboarding is one of the biggest, is one of the most common tasks that you can get. So it's not every day. Most times 90% of the time or 95% of the time, when you are hired as a Splunk engineer or Splunk admin, you would come to an environment that is already set up, that is already deployed, everything is set up fine. So what you would be required to do is continuous maintenance, making sure that everything is working fine. If there is a if there is a new data source to be onboarded, make sure you can bring that in correctly and everything. So data onboarding is one of the most common tasks that you can do as a Splunk admin or engineer. So that's why, I mean, we're talking about that. So you have set up all these different, this input here, and have defined whatever settings that you say under this monitor input, and your data is not coming in the way you expect it. These here are tools that you can then use to troubleshoot that data, troubleshoot why it is not coming in the way you want, and make it work. So that's what we'll talk about. So this tailing processor is one of the processors in the that Splunk has, that tells, that looks at the monitor, this that monitoring, monitoring data is one of the functionalities. So there is a processor that executes that, functionality. So you can try to query that processor, so it will tell you if there are any issues. So that's what it's telling here. The tailing process implements this monitor stanza. So inside of the input.conf, you can therefore query that processor into troubleshooting inputs. So this command can become useful. You can run this command, and all of this is just the Splunk command, right? Being Splunk, that's just the path, or up to here that's the path. This is the command Splunk _ internal. Remember, internal index is where all the whatever data that Splunk generates about itself. This is here, it's telling you that maybe there was an issue doing something. Remember, inside of the internal index is where it would store anything about the system itself, about Splunk itself. So you're querying the internal index, and you're calling the services admin input status, and then you are querying the tailing processor file status. So you look at all inside of the input, this input.conf, that's what you're saying, input status. Inside of input.conf, you would look at all the file status inside of there and show you if there was a permission issue, if there was anything. Guys, hold on for me. My computer wants to die. Let me just connect it quick. So yeah, so you can query that and then see the result, and it will tell you if there is maybe issues with network, if there is permissions, Splunk cannot read maybe the directory that you're telling it to monitor or whatever. An even shorter way of, looking at the same information is running the command opt Splunk bin, and then now Splunk list input status. So here you are actually going and calling the service itself and then seeing input status, and you have to reference the tailing processor. But here you can run the basic command that just say input list input status. So you want to see the status of all the inputs that you have defined. You would bring all of them, it will show you whatever you have defined under that. And you can also list monitor. List monitor will just show you what you have defined. Like these are currently what you are monitoring. It would not tell you if there is an issue with the monitor. It will just give you like a summary that this is what you are right now, the activities that you have defined in your environment. We will do, we'll run all of these commands and you'll see them. But these are tools that you can use to troubleshoot and help understand if you're having issues, how to resolve those. That's why you would use a test environment, try to bring in the data, see if it's working the way you want. And then if it's not doing that, and then fix it. So any questions there? Are we all good? Are we confused? Okay, let's continue.
I think I have a question.
Yes, sir.
Yeah, if we have to troubleshoot any problem, at what platform should we stay to do that? Because I know likely we may not do it at the indexer, at the forwarder. Should it be at the indexer or should it be at the sachet?
So good. Good question. That's a very, very good question. First of all, the thing to identify is you are having the issue. You're collecting data. The forwarder is the component that collects the data, right? So if the data is not coming in, or maybe it's not coming in at all, or maybe it's coming in a way that you don't like, that is telling you that it's the component that is collecting it that is not being set up correctly, or it's not doing the job that it's supposed to. So that's why understanding the functionalities of the different components is very, very vital here. The forwarder is what is collecting the data. So if you're having issues collecting data, you have to go to the forwarder. That's where you go troubleshoot. That's where you change stuff. You don't change anything on the sachet. So the sachet can help you understand what is happening. So remember, because the forwarder, and here, because the forwarder is connected to the indexer, and I'm saying here an example is, the forwarder connected to the indexer is sending its internal data, and the sachet is connected there as, distributed sachets enabled. So you can, on the sachet, query and see the errors. So the sachet can tell you what is going on. So remember, you can query. What we're querying here is in the internal log, right? So inside of internal log, you can come to log levels. So log levels here, it will tell you if there is just informational. Informational is just telling you this is what you did. That's no problem. Warning is just potential problems that could happen. So it's warnings. If something goes wrong, it would have an error. So if, for example, there is permission issues, it will say error and it will tell you here. So you can come to the sachet, look for, identify. So in this case, you could have gotten like maybe you have multiple forwarders. Make sure you are selecting the correct forwarder. In our case here, I'm selecting the indexer. So and right now, because we have not gotten any errors yet, we have not gotten any problems, so I'm not seeing anything. We have not tried to do something that did not work. But let me go back to log levels. Let's do this one. So inside of here, let's specify our forwarder. Let's say we were troubleshooting the forwarder. We know the forwarder is where we think the problem is, because that's what is collecting the data. And so on here now, you can then go to log levels. So inside of log levels on the forwarder, we don't have any warnings. It's just information. So meaning right now, because we've not done anything, everything looks perfect on the forwarder. Everything is good. We don't have any issues, any errors right now. You can see this here. You can go to the forwarder itself and run that command, run the, do we know, before even I say this, we've done it here. Because the file that is sent here to the underscore internal index, what file is that? Any ideas? What file? So that's the file that is sent here. That's why we're seeing this information. What file is that?
Configuration file?
Everything is a configuration file. So I'm the exact log file I'm talking about. Hint, I'm opening it for you guys. So these are the files. So inside of var log, Splunk, metrics, Splunk d.log is what is the big log. Splunk d.log is what you use to troubleshoot. So troubleshooting issues, connectivity issues, permission issues, whatever would be stored in this Splunk d.log. And the location for that is OPT Splunk forwarder, var log Splunk, Splunk d.log, that is the log. So because it's sent to the indexer, and this is the value of doing, telling all the, remember we said in your Splunk environment, you have to tell all the servers that are not indexers to send their internal data to the indexers. So that's why you are able to come to the search head and identify what problem it is. So you can come here and run the searches. So I'm looking at the internal index. I'm specifying the exact host that I think is the problem. And inside of that, I know the source is this, and the source type we know is Splunk D. So the source type is Splunk D. The log itself is Splunk D.log. And I can see that log and troubleshoot it. If I wanted to, I mean, maybe I don't like the way I'm seeing the information here, I can query that log from the forwarder itself. This location, right? This is the location we said the path is this Splunk d.log. So if I copy that, and come to the forwarder and say cat. So cat opt Splunk forwarder var log Splunk d.log and run that. You see it's a bunch of all, right now it's all informational. That's why it's just information that you're seeing. So this is the actual raw log that you're seeing, the actual raw log file. So we're seeing errors here, but why aren't they showing? We're running just 60 last 60 minutes. If I extend the time maybe to 24 hours, it will start showing me, okay, I'm just looking for information. So you see log, now I have errors. So if I wanted to see errors, maybe when it started, there was some connection to host failed. So when I was configuring this thing, there was some issues with connectivity. So I can come to the log file itself and identify what is wrong by running that command. So if I clear again here and bring this up again, and I can grep here, I can, grep is filtering. So I can grep error. If I wanted to just see things related to error, so you see it shows me all the errors. So you see that thing that I said, connection to host that failed. And we're seeing that here, connection to host that failed. So the same information you can see. So you can come to the search head and make sure you're referencing the correct, machine that you're trying to troubleshoot the issue on, and see the logs, the information here. When you've seen it, you have identified that this is the issue. To fix it, you have to go to the machine itself, the forwarder. You cannot fix it on the search head. You cannot go change something on the indexer. So you have to go to the forwarder itself. So to answer your question, success, so you can use both the search head, because that's why it's giving the logs are in the indexer. You can use the search head to identify the problem. You can identify the problem from the machine itself where it is happening. But to fix the problem, you have to do it on the machine that is collecting the data, because your problem right now is collecting the data. Is that clear?
Yes, thank you.
Yep, but that is a very good question, and we would elaborate more on that as we go. So here, so that's why you can list that input status and do all of that. Okay, and we talked about this again, another tool that we can use to just check configuration files. We talked about the B tool. B tool is a utility in Splunk that you can use to validate the correctness of configurations. So check if all your configurations, if there are like spelling errors and anything in your configuration files, B tool is used for that. So it shows the on disk. So when you save the configuration file, that the content of the file is saved on the disk, the current, information. Remember, if you want that information to be saved in memory, you have to restart, right? So that's why it's telling you, it looks at what is on disk and show you that. So request the .com file and check whatever is there. The syntax is Splunk, btool, and then the name of the com file that you want, and then list whatever option that you have after list. An example of that is Splunk command, and then you say the path there, Splunk command, btool. I want to look for the configuration file inputs, which is, we say here, conf name inputs. It knows that it is a .com file, so you don't have to add the .conf there. So just say input list. It would list the content of input, every content. Another option is I can say Splunk, btool, input, list. If I want to show the path to whatever, all the locations where the file exists, I can say --debug, or it should be debug here, not debug. Sorry, it's debug, bug. So --debug, I think it did autocorrect. I didn't realize that. Auto just took that for me. So --debug would check for the list, the inputs and all the locations. And if I wanted to say again --debug and just want to filter on a specific location, I want to see only the configurations that are in my local directories, like grep local, like I did there, where I grep error and it just showed me anything that relates to error. So grep is a way to filter in the Linux terminal. And I can even check a specific app. Again, btool, input, list, --app. So if I wanted to just reference, for example, in my search app, I want to just troubleshoot configurations in the search app, --app, the name of the app, I say search, and then, it would look at that app. So we can use this. This is really useful. Or you can just say btool check. So btool check will check if there are any errors. So if I bring up my Splunk command here, do I have my Splunk command? Okay. So if I say opt Splunk bin Splunk, and then btool check. Btool check will just check if there are any errors. If I run this, so it says right now that warning, attempting to revert to that, or that's nothing, executing, invalid. So this is the error. These are all just, common things that, that's not anything. See, invalid key in stanza webhook, opt Splunk forwarder, like it's looking at that. So there is an invalid thing. So you can go now to this location here and look for that stanza and go correct whatever line there. Sometimes we have not changed anything here, so we are seeing. So sometimes even the default configurations can have errors. We've seen that here. So it says invalid key in the webhook. But this is how you check for spelling errors. Maybe inside of a monitor stanza, instead of MONITOR, you can say MONA. It would identify those things. You misspell the attribute name instead of index. You say index, whatever. It would identify that for you. So btool is really important to use. Know that as well. And then the fish buckets. So with the fish buckets, we say is the utility that is able to remember. It has the memory to understand what file it is looking at, where it stopped looking at that file. So it would remember the next time when it comes to look at that file again, that this is where I'm going to resume. I'm not going to start over again. I would resume. So it allows Splunk to track monitored input files, right? Contains files metadata. Metadata is just data, information about the file, right? So it has, which identify a pointer to the file. So pointer to the file tells it this is XYZ file. That tells it this is it has numbers that it would identify. This is the ID of this file. That's my pointer to the file. And then the pointer again to where it last read the file. So identifies this is the file and this is why I stopped reading the file. So this this is like an index fish bucket is an index. This is like that data is stored in there. If you can refresh it, you can, you can delete it and all, but exists in all Splunk instances, forwarders, full instances of Splunk. Every instance has the functionality of the fish bucket. That's why Splunk advises that if you can monitor the data, if you can send the data to a file and monitor that file, do it, because you have then the safety of the fish bucket, where you would not lose data, in the sense, meaning if it knows that it didn't read this file, it would go read it. If it has already read this file, it would not redo it again. So you will not lose data, even if, for example, the indexers, the forwarder and the indexer lose connectivity for a while. When it comes back on, it would not, for that period, when all the data that is generated would be stored and then sent back to the indexers. But if you're sending the data through like a network device, right, and it's just coming, like you don't use a forwarder where fish bucket is possible, when the indexer and that device loses connectivity, the whatever data that is sent during that period would be lost. When the indexer, when the connection is restored, it just picks up where whatever that is at that moment, whatever is sent in that time is lost. So that's why you want to use a forwarder where possible. So if you have cases where for security reasons, or maybe for the way maybe the application is or appliance, you cannot install a forwarder on it. So that's why we introduced the concept of syslog. So you can have a general server where you can tell all these other servers or these other devices, this network, like your routers, your switches, all these other network components, to send logs to that centralized server. And then in that server, that's where you then tell this data to come and be written to different files. There is the functionality of syslog that would do that would collect that data, write it to different files, and then you can easily just install a forwarder on that server and tell the forwarder to monitor these files. So there you're not losing anything. So if the connection to that forwarder and the indexer is lost, that the data is still sent to the forwarder, the data is stored there until the connection is restored and it's being sent again. So that's why, using a forwarder is really important. So the head of the fish, we say it's a fish bucket, so it has like that functionality of a fish. The head of the fish is the pointer to the file. So the head of the fish says, this is the file. And the tail is what is showing where Splunk left reading the file. So what data has been indexed on this file. So that's what the head and the head and the tail. Any questions here? Okay. All right. So now inside of so in our case here, we are using a test environment, right? So we're trying to bring in some data sets, and then we'll see if it works for us. Okay, if it does not work, we fix it. So, or if it even comes in the way we don't want it, we would fix it and then re-index the data. So that's why you have remember we said the fish bucket. The fish bucket is an index inside of there, and inside of that index, the information is, it keeps the information about whatever data has been ingested. So that's why when you have defined an input and that data is in Splunk already, and it is on, and you have now, maybe you see that that's not how you want to see that data. It is not correct. The definition is not correct. You go to the forwarder, what Success was asking there, you identify an issue, and the issue could just be that maybe the host name was not like it is coming as Sadija Linux forwarder. You want it to show the actual device where the data is coming from. That could be just that. You want to fix it. If you go fix it on the forwarder and restart the forwarder would not re-index that data, because the fish bucket has already information that this data is in Splunk. So it would not, it would just start indexing whatever new data that comes. So whatever new data would that comes in, the information will start showing your new information that you have. If you want the original data to be re-indexed, you have to do what we call deleting the fish bucket, or deleting the fish bucket entry for that particular log. So that's what we call re-indexing the data. So you edit the inputs. So if you want to re-index the data, you go and edit the input on the forwarder, meaning you go correct it. You have identified now that the host name is not appearing the way I want it. I want to fix that. So go to the forwarder, edit input.com, fix the host field. Maybe you want to use host segment, fix that, make sure it is correct. Now, re-index the data. To re-index the data, after editing input.conf for the new data, you say it does not change or re-index existing data. To re-index, delete the old data, change the input.conf, reset the fish bucket, and then restart the forwarder. So these are the steps that you use to make sure data is re-indexed. So you've seen the error, you've fixed it, you want now the data to show in that new format. So that's what we do. So we're going to go and ingest some log files and see error, and then we'll try to fix it. And this is here just detail. So to reset the fish bucket, so we're saying here the whole flow is first, what, delete the old data, right? Because you want to remove it from your view, and then fix the problem, reset the fish bucket, and then restart. So we're saying, how do you reset fish bucket? So that's what we are saying here. How do you re-index data? Resetting fish bucket, you have to stop Splunk, reset the individual file. So the fish bucket is a whole folder or an index. Remember, an index is a folder that has information for all the data that is being collected by that forwarder. So you want to be very, very careful in deleting fish bucket. You can delete the fish bucket entry for the exact file. So this is an example of that. The fish bucket, remember, is an index. So it's in the var lib Splunk. So that's where indexes are, right? That's the default location of the index. So inside of there is the index called fish bucket. Inside of that fish bucket, you say Splunk private DB, that is the database, and then the specific file. So the source of that file. So the file could be OPT, whatever, you know, the file name sets the source of the file. Or you could delete the whole fish bucket. So if you know, if this is your test environment, you know, because remember, maybe in the forwarder, it's not just data for access log that you're collecting data for other things. If you reset the whole fish bucket, all the data will be re-indexed. So that is charging your license again. So you want to be careful. But just to tell you that you can reset the whole fish bucket away, and this goes for all indexes. You can clean an index. You can like delete the content of an index. It could be the fish bucket, or maybe it was like an index that you have data there that you don't want. Again, run the command and say clean event data index. You know, in this case, our index is underscore fish bucket. So that's what we want to clean. Or easily just run this command. RM, we know RM is removing files in Linux, right? RM-R recursive, because it's a directory. Go to this location, Splunk DB. And what is Splunk DB? Splunk DB is OPT Splunk var lib Splunk. That is Splunk DB, right? That is at least the default location for Splunk. So OPT Splunk var lib Splunk, and then fish bucket. Fish bucket is the directory inside of that. So you want to delete that. So you reference this. You say RM-RF, delete this. So when you do this, it will delete the whole fish bucket. When you start up Splunk, it would go create a new folder, an empty folder for fish bucket. Because now the forwarder would have a new fish bucket folder, it would look at the folder and does not see any records of ingesting anything. So now the forwarder would go back to all the configured inputs and re-index everything again. So that's why you have to be careful in how you delete the fish bucket, how you want to delete it. Any questions here?
So is it safe to say that it's better to use the path and then clean the data versus remove it? So you're saying it's better to use the other one? Because you
Yeah,
can
definitely. If you are you have multiple, data sources in there, definitely don't ever go to an environment and go delete the whole fish bucket. Don't ever do that. Use this format to go to the exact file and delete it for that file. You can do it on your test environment because you know you're not losing. But if you go to an environment and just imagine you would cost like that day they would just tell you, what happened? Why are we going 5 gigs above our license? Then they will realize Joseph went and deleted the fish bucket. So you see, that's a conversation you don't want to have with your boss.
not at all.
Huh?
I said not at all. Definitely don't.
So what we are going to do, I don't think we'll have time for the monitor input. We're going to simulate this issue here that we brought in data and it is showing the wrong host name, and we're going to then fix it. So that's what we will do here. So we have our forwarder. Our forwarder is working fine. I have this log. So if I exit right now, my forwarder, exit again, I'm on my MacBook right now. If I ls here, inside of here, I have this data, ww1, 2, and 3. So I want to, first of all, bring in this data into my folder. Right now, it's on my local computer. This is not something that is generated on the machine, so I'm bringing it in. So this is an example of data coming in. It's just in our case, we're manually bringing it in. This could have been like me connecting a web server. I don't have a web server running somewhere. That's why I didn't connect that. I have the data, so I'm just bringing it in. So if I do ls again, so I want these 3 directories. So we've seen how to use SCP. So SCP is, I can say, the SCP command, because I want to bring in directories. So I say -r, and then I have to use my key, my .pem key. So -i to use the key, and then I use the key test.pem, and then the name of the user and how I want to log in. And the user is ec2-user at the IP address of the forwarder. So my forwarder is this, right? So the IP address there. And then now I say colon, because I want this data to be sent to remember the TMP is the directory, because right now I'm bringing in this data as the EC2 user. EC2 user does not have full access to all the directories on this instance. So I know TMP is a directory that is not restricted, so I'll send it there. So I say /TMP, and then that's it. So reference my key and that. So let's see if that would work. Okay, didn't like oh, I didn't reference the files. I have to tell you what I'm moving. So classicals I do. I didn't, what I have to tell it, I want www and I want everything, that there. So I am, again, scp-r, because these are folders -i, and then my test key. These are the files, because I'm in downloads and these things are in downloads, so I can reference them www. So 1, 2, 3, and then I start user. So now run it. So now you see it would then send those logs for me. It's going through recursively, copying all of them and sending them in. So we can see inside of each folder, it has access and secure.log. So I can log in again. So now, so if I cd to temp, in here, I have brought in that data. So it's there, it's easy to user. So what I want to do, I want to move this data to, a directory. I'll create a directory in my OPT. I'll just call it data, Splunk data, and then put these files in there. So let's do that. Let's make MK. So let's so mkdir, make directory. I want to do that in OPT, and then let's say, just call it data. Okay. And then so that is there. So now we can move our files to there. So we are in temp. So we can say sudo mv www everything, and then we want to move that to OPT data. Okay, so let's see. And now if I LL here, it's not there anymore. So if I cd to OPT, LL here, I have data in there. So if I LL into data, so I have those log files in there. So let's first of all just make the Splunk owner, be able to read these directories so that we don't get any errors. So I'll say chown -r Splunk user. In this case is OPT data. Okay.
May I ask why you put Splunk user instead of, it's the same, never mind, it's still different. I got you.
Sorry?
Never mind, it's no different.
Yeah, because the user I created is called Splunk user, it's not Splunk. So I did this thing willfully to just tell you that you can name anything. It does not have to be Splunk. So what I realized, people were mixing the user and Splunk the application. So Splunk the user versus Splunk the application. So that's why I'm naming it Splunk user now. So the Splunk user is able to read these files now because I've made it the owner. We could have chosen other ways of doing that, but that's okay because so I have that. So now what I need to do is now define how I want to monitor this, this directory, right? And to define that, where do I do it? So let's switch to our user first, right? So Splunk _user. How do I do that, huh?
What are we trying to do?
I want to go create the configurations to monitor these directories.
You need to go to your inputs.conf file.
Okay. Where do I find that?
It's gonna be, can you LL real quick?
So if I do PWD right now, I'm in OPT.
So it should be OPT Splunk.
Okay, so CD, right, to OPT, Splunk.
Order and Etsy, sorry, Etsy. And just say input apps or Etsy input.
So we talked about this the last class. We have the different contexts. We have the app context and the system context, right? So here I want to define it in
local.
General system level. So where do
System
I go?
local.
System local.
System local.
So system local.
So
if I LL here, I have input.conf already. If I cat input, we know already what is in input.conf, that default stanza, right? So I want to then add this configuration in there. So I can say vi input.conf, right? So inside of input.conf, that is there, I say that, and then So one thing that I even want to, okay, I would just not restart the forwarder. So in here now, I want to define my input.com. So let's come in and do that on our thing here. You know, normally this is my file. This is where we would define what we want, right? So let's copy this input stanza and just fix it. Let's come down here. And what I want to look at here is OPT, OPT data, right? OPT data. Inside of that, I want it to go to, I will create this index. I've not created it yet, but I'll say Linux, my Linux index, and I don't want it to be disabled. So disabled here equals 0. So right now I'm leaving it as the default. So host, I've not set any host, so it would use my default host. I want it to use that so that we can then fix it. So we want to create a problem and then fix it. So just show you the differences. So I will copy this. So inside of here, let's paste this right now. So monitor, OPT data, yes, index, Linux. Okay. All right, let's save that right now. What I want to do is quick before I even, because I am telling it right now. So if I cut again, input, I'll be telling it to send data to this Linux index. I have not created that index yet. So I have to make sure that the index exists before I can do that. So let's Splunk underscore user. And then again, we cd to Splunk, etc, system local. Here, I'm just doing everything for system wide. I'm not creating app system local. And then inside of here, I don't have indexes, so vi indexes.conf. So indexes.conf. So let's go to our file. So inside here, we have our Linux index. We have definition for our Linux index. We'll copy that. Okay, that looks good. Okay, so I've created our index. We need to restart that. So say okay, restart. Are you guys with me?
Yeah.
Just trying to see, what did you do the index.conf? Did you make a mistake so we can read it? Is that what you did?
No, I didn't have the index, Linux index.
Oh,
I'm trying to specify in the, in the forwarder. Remember, in the forwarder, I have to tell it what index to send it to. I'm trying to say send it to Linux, but I've not created that index, so I'm creating it.
Gotcha. We'll always have to do that, correct?
You have to have an index. You can reference an index that does not exist. So when they say, when you are asked, right? When you are asked to onboard data, these are the things that you have to understand. Okay, what location are we sending this data? What index? What is the source of the data? What kind of data are you bringing in? So this is, maybe if it's a customer that does not, someone does not understand what data source, what is the type of data, meaning what kind of source type. So you start, researching how do I bring in that source type and all, and then take it from there. How do you want to bring that in? So then you would know the method. Is this a way I can just install a forwarder there and monitor that data source? Or is it going to be via a network input? Is it going to be an API that I have to create? Do I have to use a HTTP event collector? So there will be a conversation, understand. I remember one time Sal was asking a question about, they tell you need to onboard data and you need to use forwarder, and you guys were, giving answers. This thing is taking long. Yeah, but yeah, you would talk through and make sure you understand the requirement exactly before you go in. You don't just go in and start defining stuff, and make sure you're doing it on a test environment. Make sure you don't just go and define everything in production, because if you break something in production, it will be hard to fix. So I've restarted Splunk. So let's see. So I want to first make sure that my Linux index was created, right? So I say equals Linux. So you see right away, when I start typing L, it is showing me that index. So it shows that index was created. Right now, if I run that, there's nothing in that index. There's nothing in there, so that's good. So now we would go and now send the data. So if I go to my forwarder now, we've already defined our input.conf to monitor that. So all I need to do is restart my forwarder. Splunk. Okay, so we've restarted. So let's see. So sometimes the timestamp, if this data, if I had downloaded these files long ago, you would have the timestamp in that time. This was a long time ago. So you can always extend the timestamp and see. So you see, it shows me. So you see here, it says 3/18/2021. So this data was, I've had it for a long time. It's not a new data source. That's why, when the data comes into Splunk, timestamp is extracted. You have to reference that timestamp to get the data. But we can see here that we have two sources. Data is still coming in right now. It's looking at ww1. So OPT Splunk data, which is where our data is, ww1, secure.log, access.log. I didn't specify a source type. Willfully, I didn't do that. This is because I am trying to look at a directory, because data is a directory. I'm trying to say, look at everything in the directory data, right? Instead of here, monitor everything in Valog and OPT data and capture it. So if I say source type equals syslog, it would give the source type syslog to everything in data. Splunk is intelligent to understand and assign source types according to the type of data. So it was able to look at the data and understand that this is something I know, and it gave source type. We didn't specify source type, so it gave you, say, access combined W cookie, and the other one is secure. So the secure logs, the access.secure, so you see, these ones that say secure.log, it gave it the source type secure. If I remove that, and this access combined W cookie, if you look at the sources there, you'll be the access.log. So it has everything. So all the data is coming in right now. So but look at it here. So if I come to sources, under sources, so you see it says OPT Splunk, ww1, access.log, ww1, ww2, ww3 for all the access. We have ww1, ww2, ww3 for all the secure. So and we said in here that we have 3 web servers, ww1, 2, and 3. They are sending data. But because we did not we did not tell Splunk to try and make sure that it is categorically listing the exact source where the data is coming from as the host. When I look at here, it says Sadija UF is the host. This is not a correct representation of our data. This is not a correct way to represent it. So we have to, be mindful of this. So that's why in here now, because we know we are looking at a path, we can use the host segment to try to capture the correct host names here. But because I have already indexed this data, if I just easily come to the forwarder and correct it, it would not fix it. The data would not, it would not be fixed. So I have to, first of all, go make sure I remove the record of that data being brought in, and then fix it. So I can go fix it. So let's fix it first. Let's come to the forwarder. If we go to our thing, right? Our steps to fix the data. So it says to reindex the data, delete all data. Change the input.com. So delete the old data, fix the problem in the data, and then reindex the data by resetting the fish bucket and then restart. So we're going to do that. Delete the old data, reindex the data. So let's do that. Let's come here. So what we are doing here right now, our data is in the Linux index. And what we are going to do is remove the data from our view because we want to reindex it. So to delete it, I would go to there and go enable, deleting data is not, I mean, even though I am admin, I'm not giving this, so I'm just saying the time here. I'm not giving by default the permission to delete data. So I have to go grant that myself. So if I go to users, if I go to role there, so admin, that is my role. My role has these capabilities, 104. It is the most active, but you have here can delete. Can delete is another role. So I have to give myself that a role for me to be able to delete data. So I can edit this, edit the role. Inside of here, capabilities, if I search, so right now, what we can delete is not there. So so let's do this. I'll go to the index, the user itself. So let's go back. So let's go there, users. So my user is admin. So I want to edit that user. So edit that user. Inside of here are the roles that I can give to the user. These are the roles. Right now, the user has admin role. I can just add the can delete role to that user as well. So my user is administrator, right? He has the role admin. And then we'll talk about roles. What are roles? Because Splunk is based on role-based access. So if I save that, or let me do this. Let me try to delete without doing that. This is even good that it didn't work. So let me do this, right? Go back here to search and reporting. Let's run the query and just try to delete the data. So Linux index, let's just delete everything in the Linux index for all time. Run it, right? So you see the data is still there. So I can say run the command pipe delete. Pipe delete. So I'm saying all this data, whatever is here, whatever is the result that I have, I want to delete it. Run that. Say error in delete command. You have insufficient privilege to do this. So I wanted to show this. So now what I would do is just duplicate this. And inside of here, we would go back to users, then edit user, and yes, add the can delete role, and then acknowledge the users assigned to roles with the manager capability can send. No, I don't want that. Change request password change on next login. No, so failed. Okay, let me acknowledge that. Okay, so that is saved. So I have update that. So if I come back here now and just so now if I rerun this search, it would go ahead. So now it deleted the data. So you see, this is my index, and it says that all deleted, all 69,000 events are deleted. If I remove this, the delete command again now and run it, 0 event in my index. And technicality here, the data it is still in Splunk somewhere. It's just being deleted from my view right now. If there is an audit and we want to go retrieve that data, there are procedures for that. But
It doesn't
right
delete
now,
it doesn't delete the fish bucket. It just deletes it from
no,
your.
we have not gone to fish bucket here. Remember, this is right now the data on the indexer that we're deleting. The fish bucket is on the forwarder. Fish
Okay.
bucket is on every Splunk instance, but we are make sure we edit the one on the forwarder. But right now, I am saying the data on the index, Linux index, which is a separate index, because I've sent data in there. I want to go remove it first because it is not correctly coming in, right? So I want to go remove that data that is wrong, that is formatted wrongly, so that I can bring in, I can go edit the configuration file and bring in the data in the correct format. So that's what I'm saying here. That's why I've deleted it first. Clear? You got it? Is that?
Yes.
Okay, so now we will go fix the data and edit the fish bucket and bring it back in. So let's fix the input.conf. So we are in our forwarder, right? So let's go back to vi input.conf. And now, so all we need to do is tell it. So tell it to select, I like to put the host just after. So I say host. So host underscore segment equals, so here I am looking at OPT, the path to the data is OPT data, and then all the directories in data. So that's 3. So look for the segment 3, name the host according to whatever information is in that tall segment. So that's what I'm saying, OPT 1, data 2, and then wwws. So that's whatever is here is the www directories. Is that clear? Okay, so that is good. That's all we want to change. Still, I don't want to give the name of the source type here. I want Splunk to determine the source type itself. So I would save that. So remember, me changing that does not mean that Splunk could start indexing the data right away. I have to even restart for that to start. And even if I restart right now, the data would not come back. So let me just show you. So if I, it is there. So let's restart. Let's cat just so that you see cat input.conf. So you see input, we have edited this. This is the value now. So we'll restart again. So you just see, just to be sure that the data is not re-indexed because we have not edited the fish bucket. Okay, so let's go see. By right now, we should see the new data. So let's see. See, there's nothing in there because the fish bucket is seeing record that data is in Splunk. So it does not matter if I come and delete the view in the index. The fish bucket is still seeing it. So now is when we go to here. So reindex, delete the old data, change the input. So that's what we have done. Now fix the fish bucket, go and edit the fish bucket and then start Splunk. And the steps to edit fish bucket is stop Splunk, reset the individual monitors, or reset the fish bucket itself. So in our case here, since we know this is the only data we have, we can reset the fish bucket itself. So now I know my fish bucket is where is an index, right? Where is the fish bucket? So let's cd to that. Cd to OPT. Where's the fish bucket? Splunk.
Valid Splunk.
Yeah, valid Splunk, right?
Yeah.
Sorry, Splunk, not valid, brother. Valid Splunk. So it's here. So if I LL here, you see fish bucket is one of the directories that we have there. So that's what I want to now delete. But to do that, I have to stop Splunk. So again, stop Splunk, reset the fish bucket, and these are the different ways of resetting it. Reset it either this way or this way, and then start Splunk. So I have to stop Splunk first. So stop. Okay. So again, pwd, I'm in that directory. Just do status again. Make sure that Splunk is not running. So we know Splunk is off. So now we want to delete again the fish bucket. If I LL here again, I have the fish bucket. So just delete that. So when I delete that and start Splunk, you would create a new one. See, if I LL right now, fish bucket, inside of there, it has, configurations, the private DB and all of that. So if I wanted to go and delete the files one at a time, I will go into and the private, Splunk private DB, and then look for the file, the exact file, and delete it. But because I want to delete everything, I'll just say rm-rf fish bucket. So, yep, I'm okay with that. And it goes away. Don't delete it if you're not sure again. See, it is gone. Now let's start Splunk. So, let's start Splunk. Okay, now the moment of truth. Let's check again now. Okay, maybe you take a little bit. You eventually come. Okay. Okay, this is where then you start checking. Did I maybe misspell something? Is something not correct? You start checking those. So okay, it was just taking time. It was just doing what Splunk does. So let's see. All right, you see the host names are changing. It was just taking the time. Sometimes I'm not just patient. Let's give it time. It is coming in right now. Splunk is doing whatever it's doing behind the scenes. It's bringing in the data. Look at it. We are seeing the host now increasing. WW1, WW2. Eventually, so it is reading the data. So you can see this is happening. So now we are seeing correctly the data is coming in now as the host that we want. Now, if I wanted to see logs related to just host equals ww1, I can, hone into that and see what data is generated in that. And if I want to troubleshoot anything here, I can, go into it and troubleshoot, and look at that further. So that's how you fix, or override. It's called overriding the host field. So you override the host field. So you see now all our 3 host fields are showing, and we know our data, we have ww1, 2, and 3. Now it's not showing our default host anymore. So yep, and in here again, so if I clear. So yes, Clark.
Sorry, I have a confusion. So when you did the host segment 3, my confusion here was I thought it was pointing to the 3rd folder in that data folder. Does it represent the 3 folders? Because I see on the search head now it has ww1, ww2, ww3. So if there were 4 folders in there and you said host segment 4, is it going to list it as ww1, ww2, and 3 and 4 like that?
I think it's 3 folders. So let's do so ll opt data, right? Inside of data.
Yep, data.
It's 3.
Yeah, it's 3. So my question is, if we had 4, what are we going to put under inputs.com for host segment? Are we going to put 4 then?
What do you mean? If we have ww1, 2, 3, 4?
Yeah.
Oh, no. What we are looking at here is the path. So what we are saying is OPT is the first part. So that is 1.
Okay.
Data is the second segment, 2. And then the third is what is here. So that's 3. So even if
Okay.
100 folders were in here, it will give all of them the name. Each one would be the host.
I see.
So
Okay.
it's the segment path it's looking at. So
I
let's
see.
say I had OPT data and then maybe var. Before I have WW1, I would say 1, 2, 3, and then 4 before you then look at. So it looks at the path, and inside of that then gives the names.
Okay.
So it's
All
not
right.
the list of folders here. It's not the number that we're looking at. Because it is possible that even new folders could come into this data folder. So we cannot, because we cannot guarantee that, specify exactly there. We don't care. We just, all is the path. We're saying anything that you see inside of this third segment, give it that name.
Okay. All right. All right. Thank you.
Yeah. Good
Question: how many? Can you show me the path real quick for the host segment right now? Yeah, for the data, he showed me the full path. Because you said it's 3, right? I know you said we do 3 because it talks about the number of the path. Can I see the full path? Because I only see 2. I see OPT and data, so shouldn't it be the segment be 2?
Where's the third part is the WWs. Yeah, the third, that is the WWs. So OPT 1, level 1. So it's like levels. So level 1, level 2. Inside of data now, we have the third level, which is the different one. So we're saying, look at that third level and whatever is in there. So if I said 2, it would say OPT, and inside of OPT, if I had data 1, data 2, data 3, and then you would name it that way.
Bingo. Got you.
Yeah. Good questions. So yeah, so that's the fish bucket. So fish bucket is important. So I would share this with you. Go read and try to understand, the fish bucket, the functionalities, the importance of the fish bucket. Okay. So right now, again, here we have not had any much issues, right, with our data. But let's say we had issues like we wanted to list. So if I copy this list input, right, opt Splunk, and we can just run the command. We have our command there. So I say list. So input status, right? And then so it looks at everything that is defined. So it goes through. If I start from the top, remember Splunk has its own monitors, like monitors the the internal directories and all of that, and send data to the internal index. But it's telling us here that we defined OPT data WW1. Parent is OPT data, and what type is that? It's a directory. And it shows now that in WW1 is looking at the first log, access.log, file position, size of that file, parent again, percentage read. So 100% of that file is read. It did finish reading the file. So if it had read just part of the file, you will see here. If it didn't read the file, if it was a permission issue, it would show you that here. Or if like maybe the whitelist that you set did not match, it would show you that here. So this is important. It shows you all the file, what kind of folder is it, what file, and everything, even the additional things. So remember, we're looking at data in varlog, Splunk audit, varlog config, the varlog Splunk d.log, all of that is here, the health.log, all of this is Splunk, just Splunk in itself. But this is what it's showing you. That it just shows you the list of inputs that are defined and their status. So if I had said just list input, list monitor, right? List monitor. So monitor just gives me the like a summary of what I'm looking at in my environment right now. So it says this monitor directories, varlog, Splunk, all of these things. Remember, these are default stuff that is set already. But if I come under here, what we set was OPT data. Inside of that, all the directories, WW1, what files are under WW1, and then 2, and then 3, everything under there. So if you had whatever, all the different things that you're monitoring would show you here. This would just, so if you wanted to see quick, did I set, a configuration to look for something, you would set, list the monitors. So it will show you that. If you wanted to see if there is an issue with my monitor stanza, and then you do the status, which will show you detailed information of, the position, if he was able to read it completely, if there is a permission issue. So this output is similar to the output of this command as well. This is just the short form of the command. So if I copy this, most times I don't use this. This is the one that I will use. And you will see the result of this is even easier to understand than this. So let me copy this one and execute it so you see. Again, so copy that, and here. So let's run that. Again, here is just referencing that tailing processor that execute, that monitoring capability. It's the same information, but here is an XML file that it's looking at. So it goes in, it shows you the things, the values in like key value pair. So let's look for our var log, our OPT data. Maybe it's all the way up here. So you see, this one is a little bit hard to understand. You just have to know, look for. So that's why I like the I like using this. Has a little bit more detail. Move and all of that, var log, and you can always grep, now grep. So name OPT data WW1, and it shows you there again. Name parent is OPT data. That's the key. It is a directory. Remember when it tells you type directory, here it's just showing you everything in an XML format. Over there now it's just showing you the data. So that's why I like reading that, because that's more clear. Here it's showing you it's in an XML file format. So you see that, but so the input is the same information. List input status is the same information, but it's in a lot condensed, and easier to read with. So our advice, just use this. It will show you everything. There is a permission issue, you see it, and then you then work on fixing that. Yep, we don't have time to go through the scripted input, definitely, but yeah, this is monitor input. Like I said, the most popular that is used most times because it has the functionality of the fish bucket. Any questions? No questions. Okay, I know this is a lot. Again, we'll share the the information with you, share the PDF. I would advise you can start reading into the scripted input and just see what it is. So we can do that on Thursday, and the other types of inputs as well. Yes, Mr. Clark.
Saidi, you did mention that fish bucket is on every component. So is it on the forwarder and the indexer, the fish bucket database?
Yep, it is on every component of Splunk. So remember, the forwarder is its own component, right? The universal forwarder package. So there is a fish bucket there. And again, the full instance of Splunk again has a fish bucket. And a full instance of Splunk, you can configure it to serve any purpose. It can be a heavy forwarder or an indexer or anything. So yeah, so it is on anything. So let's say the full instance, you wanted to use it as a heavy forwarder, you have the fish bucket there to go edit and reset it. Just be careful, don't go delete the fish bucket on the indexer. I mean, it would not even make difference. You just maybe start throwing you errors. Like, you should know what to do, because the fish bucket on the indexer would not have any information on data it is reading, because the forwarder is what is reading the data in. So that's where the whatever history of what it's looking at. So the fish bucket on the indexer and on the searches would have no information for you. So even if you delete them, it would not change your data collection. It would just maybe start reporting errors and all of that. So, and if you do that mistake, they would know right away that you don't know you don't know Splunk.
Okay. All right. Thank you.
Yep. Other questions? Was this confusing? Was it interesting?
I said, oh, I have a question.
Yes.
Okay, I guess you already said, but I didn't get well. What happened when the forwarder went down when you were ingesting the data to Splunk? What happened to?
So yeah, so the forwarder goes down for any reason, maybe it crashes or anything. So first of all, in your troubleshooting, you would then try to identify what happened. Did we lose it permanently? It was just maybe a system maintenance, maybe the server where the forwarder was running restarted and the forwarder did not start up again, different reasons. That's a whole set of troubleshooting to identify why. So first of all, on the one of the things you would do is identify logs. If the logs are coming or no logs are coming. They have different ways they're calling it. Some they have alerts that we say check for no log returns on different indexes or different hosts. So if you have on the search head identified that I'm not seeing data from this data source, I'm supposed to see data from WW1 and it has not come in for over 24 hours now. So I know that is not normal. This data is, it's something that comes in regularly every hour or, so now that's when you've identified there is a problem here. You start checking now, okay, is there a connectivity issue? Maybe then go SSH into that forwarder and see, is it, first of all, the first thing, is it on? Sometimes it's just maybe system restarted and the forwarder did not start up. Is it up and running? Okay, if it's up and running, why aren't we seeing it? So you could troubleshoot from here and check the internal index and see maybe log level errors, again, internal, right? And see and we are checking now. Let's say we were looking at a specific you see now when I go internal, I'm not seeing those hosts, right? Because they are not connecting to my indexer as a specific server. They are coming through an intermediate server, right? They're sending data to this forwarder, and then that forwarder is what is sending to me. So connectivity will just show this, but I can go into that and then maybe go into my log levels and check errors and see, was there maybe a permission? So all the information that I can see here, if there was a permission issue reading this var log, whatever, or our log that we specify, that data directory, right? If there was a permission issue there, I can see that here under errors, it will show me that XYZ happened, this is it. So you've identified this is a problem. Now you can go to that forwarder and see, okay, is a permission, it's not reading it, or it was reading it, there was a firewall change, and then logs stop coming, or maybe the forwarder is not on. All of that, you go through the different possibilities. Elimination is what you use. You go through this, okay, it could be this, no, that's not it. Okay, what could happen? You've identified now the problem, that this is it, and then you fix it. Let's say it was just a restart that needed, you restart it, and then it comes in. But so I forget exactly the question now that you're even asking. I think I went around. What was the exact question again?
Yeah, what happened to the data? Before collecting before it stopped.
Oh, so that data is there. That is again the functionality of the fish bucket. So let's say it stopped coming because of a network. Sometimes we will see because of security reasons, the networking or security team could go decide to change some of the network settings that would then block connectivity between the servers. Yeah, log data was not coming in. Now you've identified it. If you go and fix that, that data would be stored on the forwarder there. So on the forwarder, there is a functionality, we have the load balancing functionality, right? Where it will send to indexers as per either time range or per volume. It has also queues inside of the like it has buffer queues where when the data comes, even if sometimes it's not even for when the forwarder is down, for just latency, maybe the amount of the speed at which data is coming into the forwarder, it's not the same as the speed data is going into the indexer. So there is a little bit latency. So there are queues inside of the functionality inside of the forwarder where it would hash that data or keep it there, and keep it. So if you, as a Splunk engineer, you can even increase the storage, the volume of that queue where the data is stored, data that is waiting to be sent to the indexer where it's stored. So data will be stored there until that thing is fill up. When it fills up, and then okay, that's now there is even more problem, because if it fills up and there is no way, and then you start losing data. So to at times avoid that, people can increase the volume or the storage space for that queue, so that you can maybe store data for even 60 days or even 1 month. And then by 1 month, you would have fixed whatever issues, and then you start coming. But when the connectivity resumes, it would identify, the fish bucket would tell the forwarder exactly where it stopped reading. And all that data that did not come in would then come in. Maybe you start seeing chunk of data coming in, like a very busy. But yeah, but everything will come in if it's not lost.
Okay, thank you.
Yep. So I guess here, technicality that we say we cannot lose data. So there is a possibility if the connectivity takes too long and it fills up the storage, yeah, you can lose data that way. But the possibilities are slim. And you can make you can set up, set up your environment so that you take precautions for that. So you increase the storage space for that and all of that. But we'll look into those issues maybe later. Good question.
Okay. What is the directory again? The name of the directory, the queue directory?
Where the data, where it is stored?
Yes.
So they have I forget the exact terminologies here. I can look it up. I mean, it's not coming right now. I'm not running blank on that, but they have the memory queue. So there are queues. They have the buffer queue, they have the memory queue. Memory is it will store there and just wait. If anything happens, it will just read from that memory. It has, they are called, there is the persistent queue. So persistent queue has a storage buffer also, where if it fails, if like it takes longer, because the memory queue would reset within a time range. So whenever the memory queue resets, you will go into persistent queue. And I'll look that up and maybe send you a article on that. But yeah, you have the memory and the persistent queue. And inside of those queues are where now the data that is waiting. Sometimes it's not even connectivity, it's just latency. Maybe data is coming into the forwarders at a higher speed than the indexers are receiving it. So the queues would fill up, would store that data, waiting for the indexers to be ready to receive it.
Okay, thank you.
Yeah. Any other questions, concerns, comments? All right, guys. We'll come Thursday, we'll come and do a scripted input. We'll do network input. We will do API. Thursday would be we want to finish a data onboarding this week. So Thursday we'll do APIs. We'll do HTTP event collector. So a lot to deal with Thursday. So come ready, go research all those. So network, scripted, APIs, and a HEC. HEC is just HTTP event collector. Those 4 is what remains for us to do. Go read up on them, and then let's come Thursday. Okay. All right, guys. If no more questions, I'll stop the recording.